We're going to do volumes of pyramids and cones now. This is the 5th section of Unit 11. We're putting together pyramids and cones because they are very similar. They both have one base and they come up to a point at the top. Let's get started. All right. Here's a prism, a pyramid. The formula for finding the volume of a pyramid is 1/3 area of the base times the height. You have been doing pyramids, but your height was different than this one. Notice that we actually name it with an H because our height, look at this, our height comes over here and it is perpendicular to the base. I should change that color right there on the bottom of that. It's perpendicular to the base. It is not the slant height. Not the slant height. The slant height, we had the diagonal here, or even the distance in the middle there was that slant height. It is not the slant height on this one. It is the height which is perpendicular. It's kind of inside the thing, from the top down to the bottom. Are there any questions so far? All right. Here we have a cone. Your formula is going to be very similar to this one. Instead of that big B, 1/3 with the big B, it's going to have the pi r squared h in there, okay? The height is the same as before. The height is actually a right triangle here. You have like a right triangle here with your radius. The height is perpendicular to the radius. Are there any questions about this? I have one on the table here, and I'll show it to you in a minute. It's called a nautical prism. You can pick it up and hold it.
Prism with it's a prism with a pyramid on it.
Yes, and the really cool thing about this, I'm going to just read this first here. A nautical prism. Before electricity, nautical prisms were placed on the decks of sailing ships. By placing the hexagonal face flush with the deck, the prism would draw light into the lower regions of the ship. And when I first saw this, I was like, what in the world? This is pointy. People are going to step on it and hurt themselves. But the prism side is the side that's up against the deck of the ship. And so like this table right here, they would have, and I want you to notice there is a, like what I call a lip on there. And so they would have it so that when they drop it into the ship, the wood would then come to here and there'd be a notch where it could hold on to all the way around. And so the wood would come like this. And so the sailors on the top of the ship would actually walk on this. And there'd be various ones throughout the ship. Then under the ship, the wood would be this
like
thick.
Flush.
Yes, this would lay flush with the ship, okay? And this part would come down, and the ship would come. There would be maybe a little bit of this point that you might be able to see the whole thing, but you wouldn't want to have this too much. They could hit their heads. But this part, the light from the sunshine would come through here, and I don't think they were blue, by the way. I think they were. This is
They're probably clear.
They're probably clear, exactly right. And so the sunshine would come in here, and then it would bring light down in the lower regions of the cabins, so people could then see down underneath. And so these were nautical prisms. I actually, if you ever go to Mystic Seaport in Massachusetts or other places, I think I saw one, and maybe when there were some ships we were, I don't think it was the Nina and the Pinta, but one of the ones we were noticed, I saw some. I was like, that is so cool. It's nautical prism. So then we have a prism on the bottom and a pyramid on the top.
That is really cool.
Yeah. So if we wanted to find the volume of this thing, you guys just watch this. You don't have to do anything with it yet. So if we wanted to find the, and that's actually how it would be. If I had one, I don't know if that's the exact shape size of this one, but if we had one that was 3.25, 1.5, 3 here, and then 3 inches here, we could find the volume. How would we find the volume of this?
I'm playing. I'm sorry. I'm curious.
We'll first find the volume of the prism,
Mm-hmm.
and then the volume of the pyramid, and then
Add them together. So that's exactly what we're going to do. We're going to find the volume of, we're going to find the volume of the prism part, and I'm going to tell you, instead of using the, since we don't have the apothem, Amy and Naraya, since we don't have the apothem on this one, I'm going to tell you that since this thing is a hexagon has 6 equilateral triangles in there. So we wouldn't have to do the area, because we don't have the apothem on this one. We only have the side of the edge, and remember, there's equilateral triangles, and there's 6 of them. So this is the area of the base is 6 equilateral triangles times that height, which is the 1.15. So then we'll plug it all in. Don't do anything with it yet. That's what it would be if I plugged it all in. That's the 1/3, the 1/4 square root 3s squared. Do you remember that? 1/4 square root 3s squared for your equilateral triangles. And then here's 6 of them, and here's that height. That's what would be the volume of the prism.
Equilateral triangles?
Yes, so hexagons, regular hexagons are always 6 equilateral triangles.
Oh, the hexagon itself. I thought you were talking about these
No,
equilateral triangles. only.
We're doing
That-
we're doing the
that's also
prism right
interesting.
now. Now we're going to do the pyramid.
Gotcha.
Okay? So the volume of the pyramid is 1/3 the area of the base times the height. And so it's the same thing as we had before. We're going to have a 1/3, 6 equilateral triangles and the height. So it's pretty much the same thing here. It's just with a 1/3 in front.
But they're
What-
not equilateral.
It's a hexagon.
I thought you said you were doing the pyramid next.
We're doing the pyramid. And if this is a hexagon, then the base will be 6 equilateral triangles.
Yeah, I thought you said you were doing the pyramid though.
What shape is this? This is a pyramid.
Oh,
The
I
base
see
of
what you're
this
saying.
is
the
a hexagon.
base.
Yes,
Oh, okay.
they're the base.
I thought you were talking about the extra triangles on the side.
No, they're not.
Okay.
So
now I'm
area of the base, the height. All right. So far, so good. If you were to take all this, take all these numbers here and here, find answers for them. What are we gonna do with these 2 answers once we find
Add
them?
them?
Add them together. You would get 664.54 inches cubed. All right. I don't know if that's not quite that big.
So that's how many cubes
Could fit in cubic inches. 64 cubic inches could fit. 0.54. Yes. All right, let's do examples 1 through 7 again.
From one side, it looks like it's
Cut, yeah.
Yeah, that's pretty cool. 1 through 7 again. We're going to do examples 1 through 7. So go ahead and open up your pages to 11.5. We'll do those examples. All right, we're going to do number 1. Number 1 says find the volume of each figure. Round your answer to the nearest hundredth. What shape is
wrong?
what?
Instead of watching me be wrong.
That would be really serve her right. Volume equals 1/3 area of the base times the height. All right, how do I find the area of that base?
Length times width.
Length times width. In this case, it's a square, so the length and the width are the same, so it's going to be 4 squared, right? The height is not the slant height, it's the height that's perpendicular. And that happens to be 5. So it's 1/3 4 squared, or 4 times 4 times 5.
26.67.
You need 2 decimals. 6, 7
What did you?
miles
I did.
Yes.
cubed.
Wait.
We're still going to find the volume. We're still going to round to the nearest hundredth if necessary. What shape is the base?
Hexagon.
Hexagon.
How do you find the area of a hexagon?
Half AP.
Yeah. That.
Wait
All
a
right.
minute.
How do we?
Oh, wait. I wrote that
But there's a
down.
1/3. I'm sorry.
Yeah,
There's a 1/3.
Yeah. This is,
Wait, what?
Yeah, there's a 1/3.
1/3 times 1/2.
That's stupid.
Yes, it is.
Don't worry, it works out all nice in the end, I promise.
What
If I
does
got
it?
the right answer, if I got out the
I
right
don't
answer.
believe
If I
you.
didn't, then I'm
All
sorry.
right. You're
Oh,
now
Gosh.
since you guys are really relying on your calculators a whole lot. You shouldn't really be too sad about 1/3 times 1/2. You guys just put that in your calculator. Your apothem is 6.1. I don't like writing 1/3 and 1/2 again, so I'm going to write 1/6 because you just multiply them together. The apothem is 6.1. The perimeter,
42.
I heard 42 because that's 7. There's 6 sides and they're each 7, so 6 times 7 is 42. And your height is,
12.
good job.
512.4.
Is that what you got?
What, for number
512.40? Just 4
That's
period?
not what
I got
got.
512.4.
That's fine.
Okay, well, looky there. Let's move on to number 3. All right, the volume of a pyramid is 1/3 area of the base times the height. Our base is a triangle. They have been giving you right triangles a lot. So how do you find the area of a triangle?
1/2 base.
We have a 1/3 and a 1/2 again. I'm going to we have 2 different H's here, height of the triangle and height of the pyramid. I'm putting little subscripts there for T and P. So that 1/2 and 1/3 become 1/6. The base and the height of the triangle.
6 is the base.
6 is the base.
Height is
Very good. There are 2 different 8s, though. I'm going to actually highlight the 8 we're talking about, and it's that one right there. Now, you could have switched the 6 and the 8 around because the base and the height are kind of relative depending on how you set that triangle, okay?
Oh.
All right, so the base we were just...
The whole height, right? So that's
Now we need the height of the whole pyramid,
Oh.
8.
and that is that 8 right here. All right, 1/6 times 6 times 8 times 8.
64.
I heard 64.
Yes.
64
Feet cube.
Are you sure?
feet.
Positive.
What did you?
That's what I got too. That's what I got too.
64?
Yeah. What did you?
Feet cubed. Don't forget the feet cubed. Let's move on to number 4. You can still use the
I
formula.
don't know if I got that right. It's a guess.
The volume equals 1/3 the area of the base times the height. But the base is a circle this time. You can bypass that first one altogether if you've memorized 1/3 pi r squared h.
Wait. Say that again,
What?
please. I didn't hear what you said. Say that again.
You could use this formula, but if you memorize 1/3 pi r squared h, that would be maybe the first one on your on the. All right, so and that you're going to put pi in your calculator this time. It doesn't say to keep pi. The radius is how much?
1 square.
So we don't even have to have 1 in there. You don't even if on your calculator, don't even put it in there. Just do 1/3 pi 11, because 1 squared doesn't change anything.
I'm stupid. I got 11 point. Well, wait. How many?
Oh yeah, you will get.
11.52.
How did we get 11.52? We got this 11. How did this 1/3 in pi?
11.52.
I got
This-
11.5.
0.5? 2. Okay, but is that so close to this 11? Why did this pi and 1/3 not do anything to that 11?
Because it's so small.
Because-
this is the one kid who
Because
got
pi
left
is 3.14 dividing by 3. 3 divided by 3 is almost 1. Okay, so this, you multiplied 11 by almost 1. It didn't do very much to that 11. What's the units on that?
Yard cubed.
Yard cubed.
Thank you.
Now, since you're on your assignments, they're all going to be cubed units. It comes when you're going to have your final exam. You're going to have some surface area and some volume. You're going to have to make sure you keep it together. Okay. So right now it's not going to be too hard because they're all cubed. Eventually they won't all be that way. I'll just start number 5. Number 5 is volume
Oh wait, it's just length times.
1/3
Never mind.
area of the base times the height. So that base will turn into length times width, correct? And our length times width is 12 and 5.
Yes.
Okay, cool.
So 1/3, 12 times 5, and the height of the whole thing is 11. I'm not going to take the time for you to put in your calculators. You guys can do that. We're going to move on to number 6. Number 6, same instructions as before. The volume is 1/3 the area of the base times the height. That base now becomes what, though?
5 times 8.
That's not 1/2. It's 1/3.
1/2
Base?
Oh, wait.
Is 1/2 again apothem times perimeter, right?
Yes, that's what I was.
Oh,
Good.
Yeah.
Sorry.
Okay, so 1/3 and 1/2 become 1/6. The apothem is
5.5.
the perimeter.
48.
No.
No,
Yes,
Oh,
yes.
40.
Wait. 8 times.
What?
Oh no, I
Five.
did 8 times 6.
Five.
Yeah.
5
It's
That's a
40.
hexagon.
It's 40.
times. Yes, it's
That's
not a
a
hexagon.
hexagon.
4D.
Yeah, I did 6.
Thank you.
40.
I should have disagreed before. Man, I was wrong twice when I disagreed and decided not to disagree. All right, so number 6.
Number 7.
6 is the total height. So you know what? Really quick, Brett, this 6 and 1/6
Wait,
cancels. You have less to put in your calculator.
Yes.
You did okay. So I'm gonna get somewhere in the 200 range.
For what?
226.
220,
Wait, where are you at? Where did you get a 6?
because the height is 6.
Oh, what number are you?
Oh, I'm looking
Number
at
6.
I'm sorry, I'm looking at something else. I'm sorry, I was really confused.
220 and units are?
Centimeters cubed.
Good. All right. That was number 6. I told you we were going to number 7.
Okay. Good, 'cause I knew
Number
something.
7. How are we doing with the rest of you? I want to make sure you got.
In .3.
On this last one, I got yards
Yep.
cubed. All right. This is what we did in this section. We found volume. We found volume of pyramids. We found volume of cones. Last week when we did all those surface areas, it actually made these ones easier because you now that area of the base isn't so hard. We have 2 new formulas. Hope this has been helpful. Goodbye.